And longitudinal view, see these red bands here? Here's the longitudinal view of the cardiac muscle cell. The red bands are 90 degrees to that. The red bands are perpendicular to that. So striations are perpendicular to the long axis of the cell. Single central nucleus. This cross-sectional view reveals how deep the nucleus is, way into the sarcoplasm. By the way, every bump you see, every individual bump you see is a myofibril. And again, the upraised ridges here. Each upraised ridge is one myofibril inside the muscle cell. In between two cells is an intercalated disc. So there's an intercalated disc in between this cardiac muscle cell and that cardiac muscle cell. So this is right on the border between two cardiac muscle cells. Here again, here we have an intercalated disc. So there's one cell here, there's another cell there, its neighbor over there. This neuron here, same as we did with said about the smooth. This neuron is either a postsynaptic sympathetic efferent neuron or it's a postsynaptic parasympathetic efferent neuron. Cardiac muscle is absolutely innervated by both pathways. So it's impossible to tell without further information which neuron this is. It isn't presynaptic, it's definitely postsynaptic, but we can't tell whether it's sympathetic or parasympathetic. So remember, postsynaptic neurons go the rest of the way to the actual target tissue. The cardiac muscle, that's the actual target tissue. Now, what do we have in between the cells? The innermost layer of connective tissue, endomysium. We have capillaries running through the endomysium. Let's see, what else can we point to on here of value? Oh, here it's showing the bifurcation. Cell splitting like a Y shape. There it's actually, so the bifurcation ends there at an intercalated disc. And then you've got a brand new cell on the other side of the intercalated disc. And I believe that's really it for cardiac. Any questions?